a procedurally generated talk. They talk about procedural generation, as it were. I want to quickly go over the sort of table of contents of the talk. There's a basic overview of PROCGEN stuff with a bunch of examples as applied to mostly computer games, because that's what I mostly work on. There's more slides than can actually be presented. There's at least 67 of them. And there's an audience participation thing at the end. If you're like really know a lot about procedural generation already, this might be just a bunch of kind of, yeah, we know that GIFs and stuff like that. What this is not, it doesn't include any actual code or content aimed at like PROCGEN pros, and it doesn't include any fireproofing. This talk may catch on fire at any moment. I'm Rox Flame. I'm a maker of things, not all digital, just lots of stuff. I have too many Twitter handles and multiple companies for some reason. It keeps me way too busy. I'm going to do a quick shameless plug on a few of the things I've worked on. One of them is this, like you may have seen, policy.spinoff.co.nz for comparison policy data between all the different parties. I was the lead dev on that. It's been my life for the last couple of months. I've been working on a game called Dinocorp. I got a Kiwi game started a couple of years back. Some of you have heard about it. It's got a bunch of procedural stuff in it, some of which you'll see examples of in this set of slides. Working on a board game as well, Replayability, which is quite fun, and I have with me if anyone wants to play it later tonight. And a bunch of other random sort of chaos. So I'm helping co-run a co-working space in Wellington called Level Up, and I work on a bunch of sort of interactive, silly things for festivals, with physical aspects as well, like projection map stuff and photo booths and other strange things. Alright, so what is procedural generation? It seems a bit random, to be honest. The technical definition, according to Wikipedia, computing procedural generation is a method of creating data algorithmically as opposed to manually. So what that essentially means, instead of creating all of the things yourself as a developer or an artist, you can use essentially algorithms to output stuff. You take a starting input, you modify that input with a bunch of steps, and then you generate an outcome. Now that input often includes, but doesn't have to include randomization. So you could, for example, put in the same input every time and get the same bunch of stuff output. You'll see this quite a lot in games where they've procedurally generated a lot of stuff, but every player gets the same stuff. Computers themselves aren't random, they're very designed to not be random, but we can make them seem random. This is important. Essentially, random number generators generate random inputs, but even random number generators themselves need an input. Now, this is actually a good thing. So this is where we use seeds. Now, essentially, a seed is an input that you can give a random number generator to get random stuff out of the procedural algorithm. So, if, for example, you put the same seed number in a random generator, you'll get the same sequence of random numbers that come out of it, and you use those numbers to generate or to plug into your algorithms to get your procedural content. Now, there's such a thing as a truly random number generator, which use like external inputs to generate those seeds as well, and that'll be things like, as an example, you've got things like the jitter and timing of interrupts produced by external devices, and like Linux uses those values, for example, to create like uncertainty, which it has stored in a small bit of data on the computer, and it's used often in things like encryption algorithms and making sure you get things that are not predictable. So someone can go, well, you know, if this is how your random pool works, I can figure out encryption, etc. There's some more actual random stuff computers can do these days, but seeds are really useful. Okay, so there are a lot of pros and cons to doing procedural generation, and I want to cover a couple of those really quickly. So one of the things that's both a pro and a con is like efficiency and cost. Now this is really dependent on the scale of your projects. So if you have a really small project, it may not actually be efficient to generate procedural algorithms to make your stuff. The larger your game gets, or the more replayability you want, the more efficient or cost-effective it gets to start creating algorithms to create stuff for you. You lose a lot of control usually doing procedure generation, so you can't meticulously craft your webs to exactly how you want. You kind of have to go with that. It is monotony free in a lot of senses, which is really nice. So it takes, so let's say you want 500 trees, and you give that to Jimothy, the artist that you have, and they get stuck having to make 500 trees. Well, create an algorithm to generate 500 trees based on some parameters instead, the monotony is gone. It's also scalable. Hey, Jimothy, you need 5,000 trees now. Or do we go, why would I take this job? You can just chuck in a bigger number, generate more trees. Compression, so the one algorithm that generates all of your trees, rather than storing 5,000 trees. It reduces perfectionism, and this is something that I found really useful as a somewhat of a perfectionist. Instead of spending hours and hours and hours and hours looking at like a very specific rock and being like, it could be slightly better if I carve this side off, and it should be over there. Then the next day you're like, but it should be over here. Like, it gets rid of a lot of that, because every time you boot up the thing and generate something that's different, then you kind of just have to be like, that's okay. Everyone's going to get it from experience. You get consistency. So one thing that's really good with this is you can create an algorithm that will generate essentially a consistent kind of experience. So this is kind of hard to explain, but I'm not sure where I was actually going with that. I put that in the slide the other day. This is probably nice to get less consistency with a lot of project stuff. Now I think about it. Reusability. So you create so much content, you can reuse it, you can throw plays at it multiple times, which is really good. The game gets more replayable. Manageability is a plus or a minus depending on the scale. So if your project is really small, managing a whole bunch of procedural algorithms and doing the testing for it can be quite a big overhead, whereas the larger the project is, it's a plus because you're not managing like thousands and thousands and thousands and thousands of assets, you're managing the code that creates those. Adaptability, so you can modify your procedure algorithm a bit and get a whole bunch of new stuff, which is really good, so you can play with that more. Alright. Post-net demo / gifs / random stuff. Right, this is where things are kind of fun. So I'm just going to kind of go into like a bunch of like types of generation just really quickly. The people in the room who work at grinding gear might find this just like, oh yeah, okay, sweet, we do this every day. So you got object generation, commonly seen things like roguelikes and dungeon crawlers. Usually involves things like chances of object types, randomly selected object components. And then you select random attributes on those components, and then you can put random number ranges on those attributes. So you end up creating things like item drops, for example. They have like this ridiculously wonderful item, resistal 75% max, constantly lose hit points. I love how like the original Diablo one, they're just like ridiculously wide constraints on the generation because it makes for some really fun stuff. Or you can do things like create asset variants. And this is here is made of object components. This is something that I've done in my own game. This is a little plant generator that I looked up. Essentially takes a whole bunch of plant components and just cobbles them all together, outputs a whole bunch of stuff that I can use in games. Okay, dialogue generation. Now this one is vast in terms of the scope of different things you can do with it. This can be everything from inserting the player's name to the software AI. So pretty broad. So there's lots of different methods that you can kind of use to generate bits of dialogue. And I'm not talking about like overall narrative here for the most part, because like hiring a narrative professional is usually better to generate like a lot of narrative, but you can do procedural elements in there as well. I'm talking more about like specific small pieces. So there's things like alternate words you can swap out, like Mad Lib styles, sentence part assemblers where you get like start, middle, and end of sentence and kind of like mash them all together and get interesting new combinations. Word part assemblers and generate new words, so you're just scrambling different parts of words together, create alien sounding things, plant names, all sorts of fun stuff. Then you've got like full like conversational implementations, like things like AI ML, which is like quite an old artificial intelligence markup language, which is used in a lot of chatbots. And then you've got Raft, which is like a really, really nice tool for like creating all sorts of procedural dialogue, and I just really love it. And then there's actual humans, you get humans to input stuff, or have conversations with each other, so they're generating a lot of their own narrative in the game. Here's like a really badly made chatbot that I was putting together when I was testing some of this stuff. So you just enter whatever you want and it talks back to you. And it had a whole bunch of like placeholder stuff in the AIML markup that I was using. And I was like, oh, okay, cool, this just sounds like a generic chatbot. And then there's like undefined things I hadn't set up properly. So a lot of those things, like if it gets to the end of the tree and doesn't know what's going on, it's just like, random question, just distract you. And then there's like this random thing I made a game here. This is using like random sentence assembler kind of approach. I made a game where you basically procedurally generated a whole bunch of different pointless powers that you could collect. And I was just like, oh, how can I make lots of really weird pointless powers? And I just found lots of, like in the sentence starters, like you've gained a power tool, you've remembered this thing, and then like a lame part of power, and then kind of like an add-on to that makes it even weirder. And mix it all up into some pretty strange stuff. But this is the kind of thing you can do to add humor quickly to a game with a lot of variation. So cave generation is something I've done a fair bit of and I quite like doing. You often see it in things like roguelikes and platformers. There are a few different methods that I want to quickly cover. Cellular, automata, logging, and drunken talk. Cellular automata caves essentially follow this idea. You generate a bunch of noise and you smooth it in the very basic version of it, and then you get a cave. Blobbing caves, and you generate blobs from different shapes, you connect them together, you've got, some caves. The drunken talk, you kind of choose starting points and meander upward and randomized directions, and you get caves. Here's an example from my game. So generate 0-1 noise on a grid at a random density and height cap. This is going to be just like whipping up a whole lot of possible caves. Use cellular automata to smooth it based on the number of neighbors for each cell. So if the cell has 4 or more neighbors, it becomes solid. If it's got less, it's deleted, and it starts smoothing out your noise into actual shapes. Then I do things like carve out extra random tunnels and the cyan tile types based on the numbers that I got out of the cellular automata there. Then I can do things like add custom puzzles or rooms by using essentially snippets that I've saved off that have. Here's an example like this. Here is an area where there will definitely be no walls. This is definitely walls. The grey is just like, let it be procedural. Like, it just gets overlaid, it takes whatever's already there, and then it kind of blends together. And then you can end up with, then you load your game assets from your generated tiles. So there's a little example of one of these generated things with my character running around, and one of the inserted sort of puzzle things that I've overlaid inside one of these others. So maze generation. Commonly seen in puzzle games, roguelikes, and dungeon crawlers. There's a whole bunch of different methods for generating mazes, and some of them just look kind of cool. This is the recursive backtracker. So essentially, you start at your starting point, start picking random directions through your grid. In this case, it's a hexagonal grid. If it gets trapped at a dead end, it backtracks until it's got an open space again, and then goes back out and continues. And it does this essentially until the entire thing is filled, and you've essentially got a maze. There's another algorithm called the randomized Kruskal's algorithm. Basically, create a list of walls, create a set for each cell, and each contain. I forgot how this works properly. Sorry, just watch the GIF, it's sweet. Explain a bit of that. I haven't actually used this one before, but I like to look at it. Somebody's going to spray, I think. Eventually it comes next. You can look up that algorithm if you think of the output maze there is. There's randomized prims algorithm. this one's like a multi-branching one. It starts from a point. Then you've got recursive division, so you divide your chamber, what steps you divide it, you create holes in walls, divide it again, you create holes in those walls, and keep dividing until you've got something that resembles a full maze. Then there's like cellular automata. I really like cellular automata. It seems to do some really good stuff with it. So you kind of have a starting point in the middle, and then you, much like the previous cellular automata example where I was smoothing a bunch of noise, this takes a starting point and each cell checks its neighbors, which is how cellular automata essentially works. And based on what neighbors it has, it will change its own state. Yeah, there's a thing called Conway's game of life, which I'm sure a lot of you have heard of, which is essentially a cellular automata system, and yeah, you can generate all sorts of really fun stuff with cellular automata. There's two maze generation cellular automata methods that I know of. This is one of them. I don't think I included the other one here. Okay, so you've got environment generation. This is in a lot more kinds of games. Roguelike strategy, adventure, exploration, world sims. Often uses like fractal height maps, fractal moisture maps, temperature maps, selections from different combinations, generating plants, rivers, lakes, this kind of stuff. And another example from my game. So this is how I'm generating the world maps of the islands that you land on. I start with fractal noise. Then I sort of smooth it out towards 0 at the edges, which means that it will be a contained island. Then I essentially just mapped tile types, and I've gone a bit further than this and added an additional noise map on top for moisture, which allows me to choose where the plant matter lies rather than just using height for that, which is a bit better. Then kind of load your map in from the type of thing you created. Color generation, I think given time I might just skip over this one because there's a lot in there. Dungeon generation, probably skip over that too. I want to really get to some of this part here, this is the fun part. Alright, so community generation. Now this is a part of procedural generation that I find really interesting. So you've got the ability to make all this random stuff or procedurally generated stuff, and then having the ability to have the community come in as a feedback loop to like pick things, modify them, improve it. Like you get the benefit of like outsourcing a whole lot of the generation process to other people, and that can be really powerful. Now, it's time to do some community generation. So I want you all to visit this URL on whatever device you have. Hopefully this works. I made this last night. I can't promise it's going to work because things can catch on fire. So this is where I get the audience to make slides for me to present, using a little drawing tool and titles. You can add slides. Basically, you visit the page, hit the add a slide button in the menu, and you can make your own slide. You can also vote yes or no on other people's slides. So if there's a slide that really shouldn't be in there, you can just hit no. It won't show up on my deck of slides. Anything you hit yes on gets an upvote, and I'll be ordering slides based on what gets upvoted. And I'm going to try and present these. It's going to be weird. I don't know what we're going to get. People can self-nominate to present their own slide if they want. There's a checkbox on the form for that. If anyone's having any trouble, let me know. I think on phones this might be difficult just with the drawing thing, a weird size. I did one test on a phone and the rest I tested on a laptop, so it's a lot of that one. I'm going to leave this for 2 minutes, I think, at least. How long do people want to generate slides? On the old slide here. Kilroy is here. Who knows who Kilroy is? But you know, that's the nature of procedural goodness.
It was the first meme.
Well, there you go. Next slide. So, it's pretty cool. It's got 2 yeses and 2 no's. What if it's accurate? What's the first one say? 1. Okay. The order is completely random, so you know that didn't work. We've got some user feedback. It's good. Killer is bad. So the ordering is obviously changing as people still submitting things, which is kind of cool. Go. Yes. Just this person has a huge head. And they look like they're going to explode. It's not good. Let's go. That's been uploaded here now. Spiky man? Yes. Ideas? Not sure spiky man. Maybe you generate error, whoever you are. You know, yes. What did you say? Your imagination can generate the answer. Now, this is not a colorblind safe slide, I imagine. Or it might be. I'm not sure how. It's not. I don't know what this looks like to someone who is colorblind, but I would imagine it's not. Is that fun? Not surprising. Additional visual. Lost in small problem. Save me slowly and slide there. Please help. Have some compassion. There's some dark stuff going on. It's Function interpret dance. Choose the first song on YouTube. Select random body part. Select second random body part. Attach part 1 to part 2. Recreate a new state every bit. It sounds possibly very painful. And a little, I don't know, like rapid fire twist and roll. That just seems dangerous. Funnily enough, the only browser I did test it in was Firefox, and it's okay for one slide. that's the extent of my testing. We're saving lots of trees without slides. Sure. Robert Spots. That was a different word. Game in a nutshell. This looks at space timbers. Is this a game someone's been making in the audience, or? I'm not sure. Hello. Hi. Alright, this is probably a good time to just go to general questions. It's like 10 minutes left, or 15. I'll go to general questions for a bit, and then if we run out of questions, I'll just go through some more of these crazy things. So, who has any questions?
Have you looked at more modern generation systems for like natural and organic systems, like deep learning is over the NLP to generate text that people think is real, and also like reactive diffusion systems are also equivalent to generating organic structures. Have you looked at those newer techniques at all?
Not all that much. I mean, I've only got so much time that I can do these sorts of things, given I'm trying to do way too many things at once. But I would absolutely love to be delving into more of the machine learning world and natural language processing type stuff. It's super intriguing to me, but
People we have diffusion systems. There's a neat GitHub demo lying around that shows really cool concepts really well. We've even got a maze generation set it.
Oh, nice.
Which is quite cool.
Sweet. Those really good diffusion systems.
Yep.
Cool. I'm going to take a quick note of that. Actually, could you submit it as a slide?
Oh god.
I think I did.
Yeah, it's a slide.
Excellent.
Very well.
Any other questions? You'll just really want to look at the slides. Well, you can just submit questions to the slides. Alright, what do we got? That's probably about 5 minutes to need to build the slides, right?
Close enough.
Close enough. Good generation. That's legit. I mean, some pretty much second generation stuff there. Cool. It'll change every day. Good times. All right.
That's not like
Cheese rolls. It's really hard to read on, but there's text on the cheese roll thing.
Can someone from the South Island do that? Never heard of them up here.
Yeah, I have fond memories of cheese rolls from my time at Crashers. Shen's plug. Good call.
We've never heard of that in the South Island.
Yeah, it's cool. That's an answer.
This one platform that's got
Does the squiggle-based generation method? Sorry, audience, but this is great. I'm assuming that's a start viewpoint, the red and the green. Perhaps.
Do you have any of this kind of like a user-based content generation for any of the games you've got and played at the moment, like for Dynamic?
I'm working on some stuff, which I'm not going to talk about.
Oh, right.
Yeah, there'll be some fun things in there. But yeah, I really like user content, like getting your audience engaged and creating stuff. It just kind of helps people feel like they're part of the project. It does a lot more than a very small team really could. It's a limited budget and scope. It's like a lot of really good things happening. All right. It's a sliding slide. This person's sliding. I like it. Hello again. I'm not sure if that's the same slide. Shuffles. Changing as things change. GDC. Yep. Let's have some GDC. Go to GDC. Oh. I love Jonah. Does I think this is Jonah?
yeah.
I think kind of might say like Jane or like John or there's just a few interpretations. So is this someone want to plug their company? They can if they want. Not totally sure.
White space company.
This company. No. think I've exhausted the list of slides now. And yeah, I'm actually going to just wrap up on that note, and feel free to continue adding weird random slides if you want, and like looking at other people's ones over the coming sort of rest of the evening. Yeah, I'll just say
some slides that you passed on earlier to get to these.
no. Oh, yes. Maybe I've got time to go back in a couple of days. Actually, this is a good chance to try something like this. If you go to the site that you were on and put in /vote, there's a little thing for like sections of slides that I put together where you can like pick which ones I should go into more detail on. I don't know if this is going to work in time, but give it a shot. I think there's a couple of them that I can actually put in the original set of slides as well. Just kind of go there.
Don't generate.
Now, dungeon generation is an interesting one. It's one that there's a few algorithms that I'm aware of that basically involve placing a bunch of rooms and then you connect them with a map generation algorithm, or you can have pre-constructed rooms or pre-constructed puzzles. Piece those together in different ways. For Lucky, I quite like the way that they did their sort of dungeon generation thing. Well, that's kind of not entirely dungeon, where they had like a layout where you can start from top to bottom. Actually, I've got images of this. Close this back out. Oh, got one thing up. Okay, dungeon generation. Now, I don't have too much content in here because I've not done much dungeon generation myself. Here's one example method. Place a bunch of random numbers within rooms. You fill in the remaining solid regions with mazes. You can connect those mazes and rooms to their neighbors with a chance to add extra connections and then remove all the dead ends. Now, this is a little algorithm that I found in sort of a very tired state last night and found some cool GIFs of. This is the GIF part. Already started halfway through, so hopefully I can rewind that. Starts off placing rooms, places a maze using one of the prior maze algorithms, connects the rooms to the maze, goes back through all the maze connections to find the dead ends and removes the dead ends, essentially. Then you got the way that Spelunky has done this. So they actually custom crafted every one of these sort of mini chunks. And they have this like bigger library, and they can sort of slap them together into a combination that you can navigate your way through. Now, this is something that I quite like, partly because it works well with what I'm doing. Yeah. I think that's about all I've got for you guys.